What is up, everybody? Welcome back to my channel. This is Tony, aka One Lead Code One Day. If you're new here, this channel does one lead code per day following the pattern of topics or series. That is, I'm going to be solving with you together on a lead code problem I have never attempted before. You heard that right. There is no prescribed answer. We are on the same page here, but don't you worry, I got your back, and I promise that I will submit at least one average code, average performance code at the end of each video. So here's a little bit about myself. I come from a non-computer science background, so I am no better off than most, if not all of you guys, in terms of coding knowledge. But that is okay. If I can do it, you can do it. It is all about learning on the go. And you can think of this video as a first-person gameplay of cracking leak codes. And who doesn't like first-person gameplays? Um, so without ado, let's start today's code problem. Today we continue on series 1, everything about dynamic programming, and the problem is 152, maximum product subarray. Also, I would like to announce a change of strategy, um, taking from lessons yesterday. So yesterday, if you watched my yesterday's video, I did problem 918, maximum sum circular subarray, and I took about 12 hours to actually finish and manage to submit that problem. Um, it was a heck of a day, and I went through a lot to actually get something right. But here's the lesson. If you're just taking lead code for code practice towards a skill set, maybe for a job or for your career um, path optimizations, um, then do not like spend all day long on just one problem because that's not what lead code is intended for. Um, so rather you would just try experiment the problem on your own for a bit, maybe an hour, maybe or two, depending on your pace. And then if you don't get it, that's fine. Just take a look at the solution or some other people's code submitted, and then try to learn the structure, the algorithm that people are using, and then just try to implement that on your own. Um, so there's no shame in not finishing one lead code completely by your own because nobody does every lead code on their own. Eventually, someday, some problem will get you. I promise you that. Although I've only done like about 10 lead codes uh, up to now, but I think that is going to happen for almost everybody. Um, like, I hate to say this, but don't treat yourself special, okay? You're probably not that 0.01% coding genius that is born to do this without the proper education background in algorithms. So I'm pretty sure I'm not that guy. So um, I did the wrong choice yesterday to spend all day long on one problem, and so I'm going to change my strategy today, and I'm going to work on this um, you know problems from today on a time limit. So uh, for the first hour, I'm going to try to come up with something that works. And if I don't find any hope of finishing it uh, within the next 30 minutes after 1 hour or so, I'm going to look at a problem solution and I'm trying to learn from it. And then I'm trying to implement that on my own after reading the solution or some other people's code. So this is going to be the change of strategy, and let's see how it goes. All right. That being said, let's get into the problem. Okay, maximum product subarray. Medium, given an integer array, find a contiguous, non-empty subarray. Contiguous means it's like a continuous, right? Um, Within the array that has the largest product. Largest product. What does it mean by product? Or return the product. The test cases are generated so that the answer will fit a 32-bit integer. Uh, a subarray is a contiguous subsequence of the array. Okay. Example 2, 3, minus 2, 4. The largest product is 6, right? Because you don't want to multiply odd numbers of negative numbers, right? Example 2, for this one, actually, it's going to be 0. Got it. And then we have some constraints. Length is between 1 and a large number. Uh, Actually, this is good. Like the values of each number in the list is just between -10 to 10. So uh, relatively small. But if you think about, this is because this is like a product, so these things better be small, right? The product of any prefix or suffix of nums is guaranteed to fit a 32-bit integer. Oh, that's good. We don't have to talk about, data type overflows in this case. So anyway, we're going to we're going to work on it for a bit. Let's start a Python notebook first and rename that with today's Leetcode problem number 152. And whoops, where is it? Here, 152. We're gonna just put a markdown here with the problem description and some examples. So example 1 there, right? Example 1. Also, we want to copy the constraints. Just right now, copy the constraints in there to remind us what constraints maybe we can exploit on our own. There we go. Yes, there you go. And then we're going to copy the solution template there. Right, and now we're going to go back to think about the problem and how to solve it. So it is a maximum product problem. So, and it's within like a list or an array, and we want to find a subarray. So this naturally can be solved by dynamic programming because we're looking for a maximum of something, right? And it's subarray, so looking for a subarray, it could be maybe generalized into sub problems, and we can do the bottom up approach and solve sub problems, and then solve eventually the big problem. Let's without hesitation get into prototyping. Right, so here's our first example here. And how do we do that? I mean, we can iterate, but that's probably not the best thing to do. Um, or we can try to be more strategic and think about what's the special thing about products. Product, right? So instead of sum, when we talk about products, you want to first make sure that the signs matter, right? The signs matter. That's the first thing that probably you should take into account. Like, you don't want your final product to be negative, so um, only take negative values in pairs, right? In pairs, and never singles. Yeah, only take them in pairs, right? Yeah, or let's say a multiple of 2, or not take them, or don't take them at all, or don't take them. Yeah. So this is just the first lesson here. I think it's important. And then, of course, aside from the negatives, maybe well we can just split the list into maybe two sublists, right? One is like positive, one is negative, and then you pick, and then of course you but because their position matters too, so a negative number is kind of like a door or like a barrier that you have to consider whether you're going to cross that or not, uh, because just like a door, um, but then you want to cross two doors at the same time. Like you don't want to just cross one door, right? And for multiplication, you want really as many factors as you can, because even because the absolute values are like between 1 and 10, and they're all integers, so nothing hurts. The only thing that can hurt you is the minus sign here, right? Basically, uh, the only thing hurt the value is the minus sign. If sign is not a concern, just take all as many numbers as possible in subarray, right? In fact, you want to take them all if you can. And you only stop, right? So just write that. In fact, you want to take them all if possible. You only stop, you only stop expanding uh, when, you know, uh, 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 um, when there's like one, when there's one negative value left, when there's one negative value left uh, 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 in front of you. Yeah, and and maybe some positive values behind it. There's only one negative value uh, left. Okay, so picture this, right? I think this is a good thinking. Picture this. In the end of the day, after you your picked your maximum subarray, you're left with the what's left in the what's left in the array is either 1 nothing, 2 1 negative value, and maybe some positive values on one side of it. On side of the negative value, the only negative value, right? So this is a really good picture, right? Yeah, that's a really good relevation. For example, just for this problem, right? So after you've taken your pick of your optimal subarray, you're always left with um, one negative value, either one negative value and some remainders here, right? Some remainder. We're gonna just use this bracket to indicate the remainder. So this is the one negative value that we're talking about. The one negative value left. Yeah. And then you're gonna have maybe some positive remaining. Yeah, this is some kind of like, yeah, the some positive remaining values on one side. Yeah, so this is like optionally this, and this is optional as well. But this is, optional based on, you know, existence of one negative value left. Yeah, so this is like the optional of the optional. Um, right. So in some cases, you're just left with nothing, right? For example, you could have an even easier case. If you just have, a plus 2, right? Then you're left with nothing, right? In this case, left with nothing. So in this case, we're left with nothing. Um, what about, let's say, another case where you have, a minus somewhere here, right? If this case, then, you know, you're left with just a negative one negative value, and that's it. So in this case, no, in this case, you just take them all. In this case, you just take this, right? So yeah, these are like the only three types of possible ending of the story, right? So these are like possible endings, you know, leftovers. Possible leftovers are just like these three. I think that covers it all. You're either left with nothing or you're left with one negative value, or you're left with uh, one negative value and a trailing set of positive values. It could be on the left hand side or it could be on the right hand side, doesn't matter. Because, yeah, let me just be more specific, I guess, to explain this. Fact. Um, if you have, you know, 2k plus 1 negative values in nums, you'll always use 2k of, you always take 2k of them and leave one unpicked. That makes sense, right? I mean, as long as you can take, as long as you take a multiple of two of negative numbers, you can just treat them as one for the effect. You can just treat negative numbers as if they are positive, as long as you take uh, multiple, as long as you take them in pairs, right? A multiple of two, right? This is like a further fact that that you're going to have to accept, right? Yes. But the fact you can just treat negative numbers as if they're positive as long as you take them in multiples of two. Right. And um, and that's a really powerful thing. So you can ignore the signs partially, right? And just treat the array as like a positive array. And then if it's a positive array, you're gonna take them all, right? So you really just want to search from the both ends to find the first negative value, right? So here's going to be my strategy. Count the total number of negative values, right? That's the first step. And if the number is uh, even, just return the full list, right? If the number is odd, just determine which uh, which just just pick the um, uh, the one or two you know most sideway yeah most sideway most sideways negative numbers, you know, and one numbers, and decide which uh, which, which one, and the trailing, you know, positive numbers with them to remove, to give up, right? To give up. Yeah, that's the strategy. So I'm going to just say that, right? Let me just demonstrate what I mean by saying that. I think I just found the solution, and this time hopefully it'll be quick, but let's just draw what I mean, okay? Yeah, what I mean is that, right, you're gonna have a list of numbers, right? Yeah, a list of numbers. In the case one, if like the number is even, you just multiply all of them. And in the case that, the number of negative numbers is odd, then maybe like one is here, right? Like this is like uh and one. This is like negative, right? Negative. And maybe you have an n2 somewhere here. It's a negative. So you're of course gonna take all of them, all of these inside, right? All of these in between, just gonna take them because you have um, an even number of negative numbers in between. You can take them all, and then you're gonna decide whether you're gonna ditch these or you're gonna ditch these, right? For this part, it's positive. This part is positive, right? And this is like, yeah, this is like money in the bank. I'm just again gonna say it's money in the bank, and MITB for money in the bank. So it's something you're definitely gonna take, and then you're gonna choose determine whether to throw up to give up which, right? This is a question to decide, you know, and this could be decided uh, by calculating. Let me just um, right. Let's just say that if you multiply them all, this is gonna be the union, right? Is it union? Uh, what it's not sum, right? Like sigma means sums. Um, what is the what is this? I guess what is the um sign for like all the products? I'm just gonna say P, right? This is P1 and this is P2, right? The product of all of those. If I calculate uh 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 well, sorry. I mean, if the total number is odd, that means we have, you know, a odd number of negatives within this, right? That means this within this part. So we just need one more negative number, which is to, choose which one to take and choose, and also take the positives, just the trailing positives behind it. So which one to ditch, which one to give up. We're gonna calculate um, which one's larger, right? Like calculate P1 times uh, minus N1, and then versus P2 times minus N2. And then, you know, give up, give, give up the lesser, right? Just keep the larger. Yep. Oops. Yep. That's about it. And that's, I guess, a simple enough solution to implement. So now let's try to implement this and see if it works. So now the first step is we're just going to count the total number of negative values, right? All right, step one, count the negatives. Right, for loop, for k in range, uh, or let's say just k in for num in nums, right? If num is less than 0, count plus plus, count plus equal to 1, right? We're gonna just say neg count, right? Neg count equal to 0. Let's just say neg count. Uh, let's just say n neg, right? N neg. Right. So this is how you're gonna count the number of negatives, and we're gonna decide, all right, if n neg, yeah, if n neg is even, just return the full list, right? Just return the product of the full list. Do we really want to return the product? Yes. So if n neg divided by 2 equal to what? Equal to 0. Is that how you do it? Like Python modulo? Right, the percentage operator. Python modulo operator basics. So 15 modulo 4 becomes 3, which makes sense. 17 modulo 12 is 5, makes sense. So yeah, that's what we wanted. If the modulo rate is 0, right, then we're just going to return um, how do you say, Python product of list? How do you do that? Multiply all numbers in the list 4 different ways. Wow, we need a for loop maybe, right? Yeah, something like that. For loop result. That's one way of doing it. NumPy prod. Well, we don't have NumPy. Um, there's a lambda function way of doing it. Okay. I think we're not going to do anything fancy. So we're just going to use the for loop. And also, um, maybe we can just also accumulate the product, and let's not do that. Let's just say um, for num in nums product equals product times num. Let's say initialize product as 1, right? Initialize that product initialized as 1. Well, maybe we should initialize it here. If that, and we're going to do this for loop, and we're going to return the product. Right, else meaning if the number of negative is odd, right? Then we're going to decide um, um, and we're going to decide if right pick the one or two most sideways negative numbers and decide which one to give up, right? Right. So, right. You're gonna have a leftmost negative, right? So let me just call them, right? N1 leftmost negative number, and N2 is the rightmost negative number in the list, in the original list. Um, they could be the same value if we only have, right? We're gonna say that, okay? N1 and N2 could be the same value if we have only one negative value in the list, which is okay because we're still gonna just uh, um, give up, you know, either that or that, right? So it's not a special case, it's generalizable. So else find the leftmost negative in 1 and the rightmost negative in 2. I think we could have done that in the first for loop as well, right? So um, right, if n neg equal to 0, right? So that means if it's like the first one we're finding, then n1 is going to be uh, 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 num. But hey, we also want the index number, right? So yes. So actually, we would like to, you know, k plus equal to 1. We also want to, you know, find the indices, right? K equal to 0. This is like index in the array, in the list, right? Um, so this will happen whatsoever, right? Um, n1, let's say k1 equals to k. Yeah, k1 equals to k, right? And then of course, for the last negative number in it, for the last, yeah, no, just uh, 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 mark the first negative index, and then we're gonna do this k2 equals to k as well, you know. This k2 be will eventually mark the last negative index, right? So we're just gonna use one for loop. Well, don't you think that it's gonna be easier if you just go for loop backwards? Yeah, inefficient. I know it's inefficient, but let's just work out a solution here. Right, so we already found them. So it's K1 and K2 here. Uh, and so once we found them, decide which one to give up, right? By comparing. Right, so the leftmost negative one is our index by K1, K2. So fine. Compare the product of of P1 times N1, negative N1, right? And you know N2, negative N2 times P2, right? Yeah. Let's say prod 1 is this, uh, prod 2 is this, and leave the lesser, one, yeah. Or just say take the larger one. So prod 1 equals to what is P1? So because N1 is mhm, um, mhm. So it's going to be a for loop for k in range of k1, right? So k1 is like the index before on the index before yeah, the index of the first negative. So this these k's will stand for all the positive values in p1. So product, right? Prod 1. I'm going to initialize prod 1 with 1, prod 2 equal to 1 as well. We're going to just initialize those. Prod 1 equals to prod 1 times nums of k, right? So that is going to be, you know, multiply all positive in P1. And then, of course, you're going to have to uh, take into account, you know, N1. So this is N1, right? Multiply by n minus N1, right? You're going to do the same for 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 P2. So now this is going to be K2 actually um, wait, that is if we still have anything after K2, right? So range K2 plus 1, um, if it exists at all. Mm, like if they exist at all, right? K2 plus 1, uh, um, or let's say in nums, K2 plus 1 all the way to the end. But maybe K2 is the last index possible. It's possible, right? So maybe this is out of the you know, yeah, it could. How do we express this? Like, right, maybe we just use an if condition. Uh-huh, if K2 is less than length of nums minus 1, meaning there's still some positive values left. Um, there's still positive numbers in P2, then we're gonna do range K2 plus 1 to, yeah, so let's say n equals to length of nums, and this is gonna be n minus 1, then it's gonna be that to n, right? The range of that. Um, and then we're gonna just multiply all possible values in P2, and then of course we're going to multiply it by minus n2, right? That's it. Well, if there's an if, right, we only actually multiply them in P2 um, if there is actually a P2. If not, it'll just be 1, like we initialized. Yeah. Yeah, if there are still values in there, we multiply all of them. Otherwise, we don't. And then product 2 is like that. And then now we have prod 1 and prod 2, right? So we're going to compare. If prod 1 is greater than prod 2, right? Then we're going to take, we're going to compute the rest, you know. Um, MITB, money in the bank, right? We're going to compute money in the bank. Compute money in the bank. Actually, what that means is that then we're going to take all, um, you know, take the product between nums 0 and nums, let's say it'll be K2, right, 0 and K2 minus 1. Yeah, K2 minus 1. So we're gonna do a for loop for num in nums the beginning to k2 minus 1. Um, product equals to product times num, right? And we're going to return product. Else, we're going to take the product between nums. If n2 times p2 wins, we're going to ditch p1 n1. We're going to take values from k1 plus 1 all the way to the end. Yeah, it's siren going on outside. K1 plus 1 and nums, the last n minus 1. So we're going to do nums in num k1 plus 1 all the way to the end, right? And return product. So I think we got it, but maybe we have not taken into account like the special cases, like just one value in there. So we may have to uh, find some test cases like that. But now, for now, let me just copy paste and start to use the syntax for the solution template. Input this, we want to expect 6, right? What is the function name? Max product. All right, so let's just run it and see what we've got. Whoops, we only got 6. Why is that? Well, in this case, we're going to put a debugger on because in this case, N1 and N2 are the same thing. K1 and K2 are supposed to be the same thing, and we're going to see if that's the case. Okay, K1 and K2. K1 and K2 should all be like 1, but we'll find out if that's the case. Now, let's see. K1 is 2, K2 is 2, right? They're both 2, right? That's correct. So if they're both 2, the next breakpoint we're gonna place and the number of negative values. N neg is 1, right? So because n neg is odd, so we're gonna go into the else condition, and then we're going to compute prod1 and prod2. And what do you think is prod1? Well, prod1 is going to be all of these multiplied together. It'll be 6 by 2, so it's going to be 12. Prod2 is going to be 2 by 4. It's 8, right? Prod1 should be 12. Prod2 should be let's just put this breakpoint at line 36 and see if prod1 is 12 and prod2 is indeed 8. That's what I want to see. Prod1 12, prod2 8. That's exactly right, and that's what we want to see, right? And therefore we should take the product. Oh, hold on. We should take the product. In this case, this part is larger, right? Then we're gonna take all of these and multiply by the money in the bank, or um, this number all the way up to before and 2, right? So it'll be uh, 0 all the way to k2 minus 1, right? And k2 minus 1, because k2 is 2, so k2 minus 1 is going to be 1, right? So for nums and nums, k2 minus 1, um, product equals to product times num. So the first one is going to, oh I think it should be num instead of nums. Anyway, so that's a typo there. Um, num and nums, right? So that's a pretty quick fix that we should get. Hey, but why is it 2? Because now we're getting less. Let's just yes, product, return product. Yeah, we're still gonna need the. Let's try, maybe this simple, mm, mm, this simple syntax, right? I think maybe, let's say 4, 5, 6, right? And for, this ace, no, numbers for number in numbers, right? Print number. Yeah, it is gonna print everything, all right. What about, let's say, numbers in numbers, all of that till 2. Oh, right, right. You know, for these kind of like indexing, you really need to add 1, always add 1 to the last, right? Right. So you need to add 1 to the last. So this becomes that, right? Because you need to add 1. And this one here, I think this one is fine. Now, yep, that's correct. The next test case, this one should return 0. It's kind of like a special test case, right? So this is going to be some kind of a special test case. Right. It should give you 0. Yep. All right. So how about let's just test ourselves the special case when there's only just one value in there. If there's just 1 0 in there, we should also expect 0, right? Yeah. Let's see if it actually gets 0. Yep. What if we only have like a one value of like -2? Then we should expect -2, right? Well, that's the thing. Like, if we have a minus value there, largest product, yeah, this is gonna be a problem because you have to take into account if there's only just one negative value, right? What if there's just one negative value? What do you do? Um, So now we have counted that there's like odd numbers of negative because there's only one. Well, the easiest way, to do everything is if you can just calculate this um, n here, and then if n equal to 1, you just outright return nums 0, and that's it, right? That way, yep. I think this is a more complete answer now, and let's submit it for evaluation. Test examples, correct. Let's submit. Okay. Whoa, 0, 2, and we're expecting 2. Wow. Okay. New test case to be looked at. Right. Ah, I see. 0 shouldn't be treated as positives. Right, right, right. So we need to take a lesson here. Yeah. Take a lesson. Zeros shouldn't be treated as positive. It ain't that, ain't that obvious. So zeros are like resetters. Right, right. I wasn't actually taking into account zeros in any of these, right? So we were just counting negatives. We weren't counting zeros. Yeah, so negative and zeros, they play a very different role in multiplication. So uh, uh, do I want zeros? I mean, we want positive numbers, so we don't want zeros. We're going to avoid zeros at all costs. Right, so this is going to be our strategy, avoid hitting zeros at all costs. The only the only time when we actually take a 0 is if everything else are negative values. Everything else are negatives. Is negative. Yeah, everything else is negative. Yeah, the only time when we actually take a 0 is if everything else is negative. So then what do we do? Well, so zeros are like resetters. If you find like a 0 somewhere in the array, you don't run across it. You hard stop, right? So yeah, when we run into zeros in the array in the list, um, we hard stop. So they're like spacers that or they're like those compartment doors, right? Uh, that shuts the whole array into different compartments. Yeah, zeros are like compartment doors that isolates the full list into um, compartments, right? Inner compartments that, yeah, that isolate um, the full list into compartments. That's true. And any number, empty subarray, the largest product. Right. So I think we have not really worried about zeros, right? So let's just go ahead and, let's say, everything here, uh, 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 0 was not considered in this page. Zeros were not considered in this page, on this page. So we're gonna dedicate a new page for zeros, right? This page address the zeros. Yeah. And the zeros are like compartment doors. They're like isolators, right? Compartment doors. We're gonna just take them, zeros, the compartment doors, right? So if you want to, just kind of like draw a comic to show what they are. Whoops. Yeah, if you want to just draw a comic to show what they are and use 3 pixels. Right, so if you have, oh, what is going on? Wow, my pen is again throwing a tantrum at me. So in this case, I'm just going to use my mouse to draw. Um, so for example, if this is your list, right, and you're gonna have like zeros at these locations, like 0, 0, and 0, then they're like compartment doors, and this is like compartment 1, compartment 2, compartment 3, compartment 4. So these are your sub problems, right? C1, C2, C3, C4. It shuts them into compartments, and then you're gonna have to worry about that, um, right. So actually, you know what? We can still reuse this, but this is not max product. This is like max product without zeros, zero free, right? But we're still gonna have to um, define a function, you know, that address this general zero problem. So what we're gonna do is we're gonna find all the zeros, doors, compartment doors, right? And our strategy is like, so yeah, we're gonna just basically say our strategy here, okay? Strategy, find all zeros, identify, um, and then separate, then split the full array, full list into uh, separate compartment sublists, then calculate the uh, max product array within each compartment sublist and take the max. Yeah, so this is my strategy here. First, we find all zeros, then we can split them into separate compartment sublists. Yeah, split the original list into sublists divided by the zeros, right? And then compute the maximum of the sublist product, sublist max products, right? So that's how you do it. Find all the zeros. Well, how do you do that? You're just gonna use a for loop search, right? Um, for num in nums, right? Or actually, just do k. For k in, um, let's say n equals to length of nums, right? For k in range of n, we're going to see if nums of k. Well, actually, this is not going to be very efficient. You know why? Because if you look up lists, you're going to have to scan the list, and it's going to be slow. Um, so, but it's okay. I mean, we're going to optimize it later. If num list k equal to 0, if we found a 0, right, equal to 0, uh, we're going to add that to, we're going to split. How about let's split them in here now. Um, can we do that? Well, we can append a list, right? Um, zero list, right? We're going to do that, and zero list append k. Yeah, so we found all the zeros here in the zeros list. Right. But if, how to check if it's empty? Uh, Python check list empty. How to check if list is empty? Length. Okay, makes sense. If length of zeros list equals to 0, we're just going to return um, self dot max product 0 free of nums, because we know it's 0 free. Else, we're going to divide, else we're going to split the original list into sub lists divided by the 0. So for each um, 0 in zeros list, right? For each of the 0 in zeros list, it is going to be, how do we chop it? How do we chop this list? So let's just draw that. So this is like the first one, right? We're gonna have a zeros list. Let's say it contains what? Here, k1, k2, k3. That's the case here, right? Because this is gonna be k1. Well, no, let's forget it. This is k1, this is k2, and this is k3, okay? And these are our zeros. And so the way we're gonna split all these lists the first list, the first list sub list one, of course, is going to be from the original nums of from 0, from the beginning all the way to k1 minus 1, right? But we're going to just use k1 because that's how this column works. It's only going to count up to k1 minus 1. Yeah. Uh, right. And after we've done that, shall we just mm, yeah, we're gonna update like the beginning. Yeah. And start, right? And start. And we're gonna update in start. Yeah, we're gonna do like an in start. First it'll be 0, of course. That's initializing. And then k1, and then we're gonna update in start. This now is becoming k1 plus 1. That's the new start, right? And then the second list will be in start all the way to k2, right? And then we're gonna again update this in start to be k2 plus 1. And then the next sub list will be in start will be k3, right? Right, 2 sub list 3. Um, if we do have a sublist 4, k3 equal to plus 1, and if we do have a sublist 4 there, um, it'll be in start uh, to the end. I mean, something like that. Yeah. That is if we still have something. Yeah, let's say this is if mm, k3 is less than n minus 1. It only happens if k3 is less than n minus 1. Then we're gonna have this, right? Because there's a chance that this 0 is the last one in the original list. So here we go. We have an iterator. Yep. So um, for zeros and zeros list, right? Uh, we're gonna see int start. Yeah. We're gonna int start equal to 0. Initialize sublist start index in original nums list, right? Um, so for that, our sublist equal to um, nums in start until k1, and start all the way to 0, right? Because yeah, that's how you do it. Um, mhm, to the first 0, um, and then well, there's an if condition. If 0 is less than n minus 1, right? If we're still not at the end of it, we're going to do this, and we're going to do this, and we're going to um, send the sublist what to calculate that, right? Um, right. Um, we're gonna do sublist max append. Right, we're gonna append that, and sublist max, we're gonna say it's that container for sublist uh, max products. We're gonna append that, right? So in the for loop like that, we have implemented this if condition, right? So this helps to define, if we're hitting the end of it. Um, and so we're gonna do this until K1, this until K2, this until K3, and then we're gonna update in start. After we've done that, update in start. How do we update in start? Well, int start equals to 0 plus 1, right? Yep. Um, shall we actually use a while loop because, well, we're gonna do for loop, and since we have three of them, this is only gonna create three subarrays, subarrays, and it's not gonna work on the number four, right? So this number four is something, you know, all these are like the for loop, right? This is gonna be like a for loop, uh, and this is like the last treatment, right? The special treatment here. And for the for loop, we really don't need to worry about this because we're just taking the subarray before these zeros. So, right, we're not going to be worried about that. And, after all of that, see if there are still um, numbers after the last zero. If 0 last is less than if this is like less than n minus 1, that means yeah, we do still have some array there. Then we're gonna do another sublist equals to int start, which is gonna be 0 minus 1 plus 1 all the way to the end, right? And then we're gonna still do this sublist append, and then we're gonna compute the maximum. All right, I think that's all the sublists. We're gonna compute the maximum of the sublist max product. So we're gonna return actually the max of sublist max, right? Yeah, so this is a prototype. I don't expect it to fully work. All right, so there's something here. Int object is not. subscriptable. Oh, okay, because there's only one zero, so I guess that's why it throws a tantrum at me. Actually, we're at the last zero, right? Oh, zeros. Yeah, zeros. You should say zeros. So that should work now. Name zeros is not defined. Okay, okay. Okay, zeros is not defined. Hmm, zeros list. Right. Okay, that worked. What about the rest? 6. Well, this went wrong. Um, wait. Expected 6. How can you expect 6 in this? This is like weird. Expect 6, right? Let's see. Expect 0, -2, 0, -1. We should expect 0 for this. Let's see. Well, this one actually produced -1. Wow, okay, so these two are problematic. We have two problematic cases. But I think I know what's going on. Because we said that, excuse me if you remember, we said that the only time that we actually take a 0 is if everything else is negative. We have not implemented that, right? Um, if everything else is negative, which is the case here, then we're going to take a 0. So where do we put that special case? If like everything else is negative, if everything else is negative, right, right, we can do it here because we don't really care about the value of the sublists in here. We only care about it at the last moment, right? Um, right. So let's say it, um, if all the sublists are um, negative, right? Can we still return negative somehow? Yeah, we could still return negative somehow. If all the subarrays are negative, we rather just return 0. Yeah, if, yeah, let's just calculate result equals to, you know, sublist result if sublist result is less than 0, return 0, else return this. This is probably gonna fix one of those problems, but then what if we only have 1 0 in there? If we only have 1 0 in there, Yeah, so what happens if we only have one zero in there? Um, Again, we want to add this in there, right? If n equals to 1, we just, return whatever is in there. Yep. All right. So I think we just did a hot fix for that singular case. And now 600 minus 2, 2. Um, Looks all right. Let's just submit it to Leetcode to see if it now satisfies the problem definition. Simple test cases were correct, but we still got a wrong answer here. So 0 minus 2, 0, we should expect a 0. Okay, so there's something that we're still not considering correctly. Oops, what did we just do? 0 minus 2, 0. For this one, we're expecting 0. And what do we get? We are getting 1. I see. I see. Huh. But hey, I mean, shouldn't we in this case, return 0? Because in this case, the sublist result is like less than, all of them are like less than 0. And you should just return 0, right? So now let's just try it. Okay, restart the kernel. And after that, we start the debugger. And we set the breakpoint at here. We want to know what are the sublist results. Because according to this, the sublist result should be like a -2 or something. Wait, oh yeah, did it go there? Yeah. Sublist result is what? 1? Really? Sublist max is a list, and it's got a 1 and a -2. Wow. How come we have two sublists? That's so strange. Um, right. So the sublists. Okay, this is where we, for 0 sublist, because the first 0 is at 0, so it's going to be nums um, 0 to 0. Okay, it's going to be nums 0 to 0. Um, what is 0 to 0? Right, this because, yeah, the int start is 0, right? And then the first 0, because the zeros list is going to be 0 and 0 and 2, right? Yeah, so this is going to be 0, 0. And what happens with nums 0 to 0? I don't know. Um, we'll find out. Like, yeah, what is going to be numbers 0 to 0? What does that return us? Let's try that. Empty. Okay. So if it's empty, then max product 0 free with an empty sublist. So what do we do with empty sublist? Are we going to return Yeah, we're gonna return something called a 1, and that is totally wrong. So we're gonna have to account for the cases where the list is empty. So what to do if the max product of that is like we shouldn't be sending empty lists to it here, right? Because by design we want to make sure that this zero, the first index in the zero, um, is not zero. Because if the first element is zero, we just ditch it, right? We just ditch it. Right. We want to make sure that the first one is not zero. Make sure, yeah, make sure the first one. If right, we're gonna say if if k1 equal to zero, just ignore, just ignore it. Right. If k1 equal to zero, just ignore it. So how do we ignore it? Well, zeros list. Uh, uh, let's say, yeah, we can afford if zero is not equal to zero. We can afford this, right? Because there won't be like a huge number of zeros, so we can afford this computation. Yep. But actually, uh, um, even for this, yeah, we're still gonna update the int start in that case, yeah. So it's just that we don't make a sublist for the first if zero equals to zero. If the first zero is at index zero, we don't do that, yeah, just like that. Whoa, what is wrong? Okay, we didn't include a colon. Right. So that is okay. And let's try everything else. Expected -2, 0, 0. Yep. Now this seems correct. Let's just submit it again to Leetcode. Let's just directly submit it. Okay, accept it. Great. And our runtime actually beats most people. Great, great. So that means our algorithm really is pretty neat and efficient, and memory usage is fine because I think we could still improve by you know removing some of the unnecessary variables. I guess we can improve that still. But I mean, this is not bad, right? Beats 99%. Let's submit it again. Whoops. It only beats 19%. So, and now this beats 76%. I guess it's like above average. So, all right. It turned out today's coding is pretty smooth, and I'm going to. So before I wrap it up, let's take a look again at what we have. So we had basically several key insights into the problem. The first insight is that, signs matter. Um, and then the only thing that can hurt the product value is the minus sign. So we need to be careful how we deal with minus signs in the list. Uh, and uh, the only thing we need to differentiate is whether there's like odd numbers of minus signs or negative signs or even numbers of negative signs. So for the odd case, for the even case, we just take them all. For the even case, for the even case, we take them all. For the odd case, we're just gonna have to make a choice between taking the leftmost negative sign or taking the rightmost negative sign. We're of course gonna take everything in between as well. And this discussion is, without the consideration of zeros. So then we went on and took the consideration of zeros. So zeros for multiplication tasks, they're like compartment doors. They shut the list into separate compartments, and that's what we did. So we had a more higher level function that identifies these compartments, and then we're gonna use um, another subroutine or another function to compute the max uh, within each of those compartments, and then come up with the maximum of them. And that is it, guys. That's our algorithm, and it worked beautifully. Um, we got accepted, and it's an above average code. Um, so that's it. Lastly, let's take a look at some of the solutions there. There's of course the brute force. Iterate everything. Your complexity is gonna be high. Oh, by the way, what is our complexity? I mean, for our problem, our complexity, right? We probably have, in terms of time complexity, um, O of n, because we didn't have anything that is like a for loop instead of for loop with respect to n. So we probably only has that. And in terms of space complexity, are we remembering anything like extra complicated? Um, well, we do have for loops, right? But for loop is not a memory. So we are sending the subarray into functions. So I don't know. It's somewhere between O of 1 and O of n, I guess. Somewhere between O of 1 and O of n, right? Yeah, something between there. I'm not quite sure, but yeah. Now, this complexity, yeah, the computation is pretty heavy because if you use brute force, you're gonna have to sweep the beginning and the end. Dynamic programming, yeah, two things can disrupt your combine. Zeros, negative numbers. Right. Zeros will reset, negative numbers is a little bit tricky. Single, right, so you're gonna have to think about odd numbers or even numbers. You're gonna use dynamic programming to compute your thing, and it's ON and O1. So actually, I think we could have tried the dynamic programming approach here using uh, this intuition here, but ours is not bad, so I'm gonna just sit on it. And if you're interested, you can take a look at the solution here for the dynamic programming solution, right? Um, it's a Python 3 dynamic programming solution. And then in the discussion, of course, you can find, wow, okay, you can find people's solution there. This guy's face show up a lot, I guess. He's really cool. Um, right. And you can read some of the codes in there. More simple. Wow, this is really a simple code. Anyways, there are multiple ways you can attack this problem. Um, and I just did it in my intuition. Um, Let me know if you found, my code could be improved in any certain ways, or if you found like a smarter trick. Let me know in the comments. And thanks for staying along with me. And I'll see you in the next video. Oh, wait, hold on. Today's summary. I think we just walked through our summary. So, all right, that's it. I'll see you in the next video.